Welcome back, AP. 16.8, acid-base properties of salt solutions. Okay, let's do a little review from back in the day. Nearly all salts are strong electrolytes. Remember, strong electrolytes, all salts, because they're ionic compounds. But it didn't say the word always. It said nearly. Okay, and remember, if they're strong electrolytes, they 100% completely dissociate. So therefore, salts in solution, they're ions. Okay. Remember acid-base reactions. So an acid usually starts with H, and the base usually a metal for right now, and my OH. Okay. And I'm going to produce the H, and remember it's going to dissociate between the OH, so I'm going to get my water. But then I'm going to get that metal is looking at that X. Now the X could be a nonmetal, could be a polyatomic, but the metal always goes first because he's a cation. The question is this, okay? Usually it's aqueous, but I want to know what's the pH of that salt. Well, I know I have an acid that has low pHs, and I know I have a base that has high pH. But when you do this reaction, what's the pH in the end? Okay, and we call this hydrolysis. So to determine the pH of the salt, you have to see where the salt came from. What part of the salt was formed from the acid and the base? So we got to figure out which ion came from the acid and which one came from the base. Okay? So think of it like this. If I have a weak acid, strong base, I made this salt and obviously water. That Ba came from a strong base. That C2H3O2, that came from the weak acid. Who's dominating that salt? So the salt is basic. So that means the salt will have a pH greater than 7. Because the Ba plus 2 came from a strong base, and that acetate came from a weak acid. The strong base is determining the factor of the pH. So basically, which of them in that salt, which of the ions are dominating that salt to make that pH either low, high, or 7. So it's a prediction. We're not doing any calculation. Can you tell me if that salt is acidic, basic, or neutral? Okay? And then we're going to list them in order of increasing pH, which means I want low pH to high pH. Okay? All right. Well, we did this one right here. So the way I do it, I show my work. Okay? So remember, the Ba, the metal, came from OH. Okay? Because that's a metal that came from OH. So remember up here, metal, OH, that's your base. BaOH, that's a strong base. That C2H3O2, because remember, it's going to dissociate right there, that came from H, C2H3O2. That's a weak acid. So this base is dominating it, which means this salt, because these are all salts, this salt is going to be basic. So it's going to have a pH greater than 7. If you have a polyatomic like NH4, it's going to dissociate right there. So this beginning ion always came from the base. Well, NH4OH, I'm going to write it over here, is another way of writing NH3. They go hand in hand, okay? So we know NH3 is a weak base. And this Cl came from the acid, HCl. That's a strong acid. That acid is dominating that pH. So this salt is going to be acidic, which means its pH is going to be less than 7. Okay? What if you have an even longer part of the molecule? Where would it dissociate? Well, I don't know about NH3 and then CH3, so that means I dissociated right here. Why not over here? Because I don't know any acid CH3Br, okay? So I know it didn't dissociate there. And you're going to recognize this NH3CH3 when we do our Kb, because our Kb, there is a NH3CH3OH. Definitely weak base. That's no strong base we know. HBr, well, that's one of the 7 strong acids. Same thing. dominating from that strong acid, which means same thing, acidic. And then the pH will be less than 7. Where would it dissociate here? Between the K and the NO3? Well, I'm going to dissociate between that metal that came from OH, strong base. NO3 came from the acid, HNO3, strong acid. Well, what if they're both strong? That means nobody's dominating. That means it's neutral. And then your pH would be 7. Okay? That's how you figure out the pH of a salt. So here's some rules. Okay? If you have a strong acid and a strong base, that means the salt is going to be neutral. So like NaCl dissociated here, Na came from OH, HCl, strong base, strong acid. Same thing here, even if it has parentheses, it's still dissociated. So CaOH, strong base, HNO3, strong acid. Okay? You just go through to figure out how it breaks up. If you have a strong base, weak acid, the salt is going to be basic. Okay? So the salt will be basic. So where did it dissociate? So the NaCl, it's going to dissociate right here. So this sodium came from NaOH, strong base, and ClO, HClO. Now be careful with this one. With only one oxygen, this is a weak acid. Okay, so remember the base is dominating. We already did this one from up above. So BaOH came from a strong base. HC2H3O2, weak acid. So remember that base is dominating. Okay. If you have a weak base, strong acid, that means the salt's going to be acidic, and it dissociates between that polyatomic and HCl. So NH4OH, weak base, because remember that is the nether way. We're going to write it over here again. That is another way of writing NH3. Okay, so ammonia. HCl, strong acid, so that acid is dominating. What if they're both weak? Okay, so what you have to do for something like NH4 that came from OH, so weak base, and CN, HCN, weak acid. So what happens is the pH is approximately 7, but it's not going to be exactly 7. So what you have to do is you have to look at the Ka and Kb values. So what happens is the Ka value is smaller than the Kb value. So that means because the Kb value is larger, then that means the salt's going to be basic. So if they both come up weak, you got to look at the chart to see which one's the larger value. Okay? And that Cn is going to be larger, which means that base is going to be, that salt's going to be basic. Okay? Here are a couple examples. I'll do the first one with you. You guys get the other ones. Indicate which salt will form the more acidic solution. So where does it dissociate? And a lot of times that's where students have the hardest problems. So Na came from OH, just like Fe came from OH. NaOH, that's one of our strong bases. Anytime you see transitions in OH, you know that has to be weak base, okay? Because the strong bases come from group 1 and group 2. HNO3, and notice it's also HNO3, strong acid, okay? So this salt, it's going to be exactly 7 because it's a strong and a strong. Nobody's dominating. But this strong acid is dominating the salt, so that means this pH is going to be less than 7. So indicate which salt will form the more acidic solution. Well, this second salt will, because the pH is going to be less than 7. Okay? So you try B, C, and D, and let me know what you get. Okay? This up here, just remember, we didn't put them in order, pH. So who has the lowest pH? Well, we actually have 2 of them right here. These 2 have very low pHs. I don't know which one would have a lower pH than the other one without doing any math. So all I know is NH4Cl and NH3 H3CH3. They're both going to have the lowest pH. Then the highest pH will be this one that's neutral. And then the highest pH will be that first salt that came from that base. Okay, so that would have the lowest pH, neutral, and the highest pH. I always get this question. I'm going to go back to the bottom example. Right here, HNO3, but it's parentheses 3. Does that mean it's 3 times stronger? Yeah, it actually is. Okay, that means you have 3 times the nitrate than you have over here. So either way, you still were acidic because that strong acid was dominating. Okay. You tried B, C, and D, and we got one section left to go. See you on the next one.